Okay, we're going to start with problem 27 on page 710. And in that problem, we have this diagram that shows a charge in the middle of two concentric spheres. The charge in the middle is 2.0 nanocoulombs. And we have these points A, which is over here. B is over here. And they're both on a circle that is 1 centimeter from the charge. We also have a point C, which is on this outer circle, and the outer circle is 2 centimeters away from the charge. Okay, and the question has two parts. The first part says, what is the electric potential at points A, B, and C? Now, in order to solve for the electric potential, we're going to have to use one of the equations from the book. So VA is going to be 1 over 4 pi epsilon naught times QA over the distance. Okay, so in this case, we're going to start plugging in numbers. 1 over 4 pi epsilon naught is the same thing as K, which is 9 times 10 to the 9th Newton meters squared per coulomb squared. Then we're going to take this number times the charge. That's going to be 2 times 10 to the minus 9th coulombs. And that's going to be divided by the distance from the charge, which in this case is 1 centimeter, so 0.01 meters. When we calculate all that out, we end up with V at A is going to be equal to 1,800 volts. Now, if we were to look at point B, since it's on the same circle, it's going to have all the same values. So this is also what V of B is equal to. To get C, we're just going to use the same equation, but we're going to make the distance longer because it's 2 centimeters away. So we're going to have 1 over 4 pi epsilon naught times QC over RC, 9 times 10 to the 9th Newton meters squared per coulomb squared. Our charge is still the same as before, but the distance is 0.02 meters, which means we have C is going to be equal to 900 volts, and you'll notice that's half of what it is at the other location. The voltage, or the potential, scales linearly with the distance from the charge. This is different than the electric field, or the potential, which tend to, just the electric field, which tend to run with the inverse squared of the distance.